This method can help address a common problem in liquid crystal research, which is that molecular motion during their photoresponse cannot be determined by conventional methods. The main advantage of these techniques is that the structure and ultrafast dynamics of photoexcited liquid crystal are obtained both from differential IR spectra and differential electron diffraction patterns.
I will be demonstrating the time-resolved IR vibrational spectroscopy.
To prepare a solution phase sample for time-resolved IR vibrational spectroscopy, dissolve 0.025 millimoles of PiCO in 25 milliliters of dichloromethane to obtain a 1 millimole per liter solution. To prepare a liquid crystal phase sample, cover a 3 mm thick calcium fluoride substrate in PiCO powder. Place the substrate on a hot plate and melt the powder at 100 degrees Celsius. Turn off the hot plate and allow the sample to cool to room temperature. After preparing the sample, turn on the titanium sapphire laser and the chirped pulse amplifier and allow them to thermally stabilize. Set the pulse duration to 120 femtoseconds, the repetition rate to 500 Hz, and the incident fluence to 1 millijoule per square centimeter. Check the power and stability of the UV pump and mid-IR probe pulses, and realign the optical paths as needed. Cool the mercury-cadmium tellurium IR detector with liquid nitrogen.